zeros and sevens. So I only take zeros and sevens. Turns out that's linearly separable because they don't really look very much alike. And so that's in the space. These are 16 by 16 pixel images. Sorry, 28 by 28. So 700, whatever. Or 16 by 16. It was 256 dimensions. Anyway, so it's basically a 256 dimensional space. And this is my training data set. These digits here, right? So this is my entire training data set. It's a small training data set. And what I'm showing you now here as this box is the weight vector, right? So the weight vector is also in the same space. So I can visualize it as an image, right? It's by 256 dimensional vector. I can plot it as an image. Okay, why not? So right now, it's all zeros, right? So that's gray. White is positive, you know, that's kind of negative. So right now, all zeros means gray, okay? So now I go through my first image, this 7, and I misclassify it. I classify it as a 0, because 0 times whatever the pixels are is 0. So I get this point wrong. So what do? I add this point to the data, to the weight vector, and this is my new weight vector. Okay? Actually, I subtract it, sorry, because it's a negative sample. Does that make sense? Raise your hand if that demo makes sense. Okay, now I reclassify. All right, so these are now the reclassifications. So currently what I'm classifying, everything is negative. Okay, that makes sense, right? Because so far I've only seen one example, and it was negative. So if I take the inner product of this vector with my entire data set, every example is negative. So now you go to the next example. Before, everything was classified as 0. That's why they were all here. So the y-axis here is basically for every single image how I classified it. If it's up here, it's positive. If it's down here, it's negative. So now I'm classifying this guy here. Well, I'm classifying as negative, as a 7, but it's actually a 0. Right? So I got it wrong. So what I have to do, I have to add this to my weight vector. Right? So this is what happens. Right? So now I actually have this kind of, it's half the 7, half the 0. Right? If I now reclassify things, you can see now this guy is classified positively. Right? So now I go to the next. Oh, it's already everything is correct. Well, that was pretty easy. Let me do it one more time because that's, you know, you got to make it worth it here. Okay, so here one more time. So I have the first one. I get it wrong. I get it wrong. So I make it positive. Second one. So here's actually here's my weight vector. So now I get the 7 wrong. So I subtract the 7. Now things are reclassified. Now I go to the 0. This gets classified correctly. Next 0 gets classified correctly. 7 gets classified correctly. Everything's correct. Awesome. Feeling pretty good. And now this guy. Oh, what's going on? It's still correct. I think the top left corner. No. Maybe I think it's wrong. Okay, maybe it's the center. Okay, so I have to update my vector. Yep. And I move this guy up. Oh, that was too much, right? So now I have to get the 7 wrong. So I have to, subtract it again. And do we have it? I think we got it. All right, good. Does it make sense? Thank you. Yeah, question?
Based on the visual diagram, it seems like sometimes you were minusing, sometimes you were adding the...
Yeah, so the negative, the points that have negative label, these points have -1. So these I'm subtracting. And these here, the ones, the zeros, they have a positive label, so I'm adding them. So what I do is w becomes w plus y times x. So y is either +1 or -1, right? So that's why I'm adding these guys and I'm subtracting these guys. Yeah, good question. Any other question? Yeah?
Does this program work for like any numbers? Because I'd like to see like a 1 and 7 things that are slightly more close together.
Well, if it's not linearly separable, it's just going to loop forever.
Oh, okay.
Right, so that's the problem with it. There's no check of is that even possible, but you just assume it's possible. Yeah? Oh, that's right, yeah. So y is actually the y of that particular data point. Absolutely right. Yeah?
More efficient way to train this instead of looping and then seeing how many mistakes you made?
We've evolved a great deal since 1957. So there's much more efficient ways, right? So that was basically, this was the first algorithm to do this. Yeah. So later on in the course, you basically take this intuition, and I will show you much more efficient ways of doing this. That's a good question, though. It is extremely inefficient. Yeah. Any more questions? All right, let me close this.